Hey guys, welcome to this new story. Before we go anywhere, take a moment to get comfortable. Let your body settle into the spot you've chosen for the night. Shift your pillow if it helps. Let your shoulders relax and let the weight of the day slowly melt away. There's nothing you need to do right now, nothing to remember, plan, or decide. For the next 2 hours, your only task is to listen, to drift, and to let yourself float with the story. In this journey, you'll be carried on a slow, uninterrupted flight above Saturn, a planet of vast storms and mysterious rings. The clouds swirl endlessly, shifting in colors you can almost feel. There are no sudden moves, no surprises, just a smooth, gentle glide designed to help your breathing slow and your thoughts float freely as you listen with your eyes closed. I'll be with you at the start, guiding you softly, and then, gradually, I'll step back, letting your imagination take the lead as you travel above this enormous spinning world. As we begin, picture yourself weightless, held, safe, and unhurried. Beneath you, Saturn rotates, its bands of clouds rolling and twisting, vast storms moving without hurry, untouched by your presence, timeless and immense. We'll drift together, slowly, carefully, at a pace made for rest and calm, not for thinking or action. For now, just lie still and let your journey through Saturn begin. We are approaching Saturn. The planet grows slowly in view, a giant ball of soft golden light framed by rings that stretch beyond sight. From here, the sun is far, but its light still touches the planet, scattering through the upper clouds and glinting on the edges of the rings. You can feel the cold of space, though there is no wind, only the still emptiness. Saturn hangs quietly in the black, and its rotation is slow, steady, and almost imperceptible from this distance. Its shape is not perfectly round. At the equator, it bulges slightly, a result of its fast spin, though from here it seems calm and balanced. The rings are thin but immense. They reflect sunlight, showing subtle shifts from pale cream to light brown. Each particle, from tiny ice grains to larger rocks, moves in its own path, but together they form a perfect, continuous pattern. The space between the rings appears dark, yet these gaps are as important as the material itself, revealing gravitational effects from the moons that circle Saturn. Even from far away, the motion of these particles is gentle and precise, a quiet dance guided by invisible forces. Saturn itself is composed mostly of hydrogen and helium. You cannot see these gases individually, but the clouds above the deeper layers display hints of their nature. The upper clouds carry pale yellows and golds, with streaks of subtle white or brown. They are arranged in bands that circle the planet, aligned roughly with the equator. The bands seem to move, but the motion is slow. They are caused by winds that can reach hundreds of kilometers per hour closer to the equator, yet from this distance, the atmosphere seems still, a vast, calm face. Looking closer, small storms appear as white spots or faint swirls. They can last for weeks or months, some appearing as tiny dots, others larger than Earth. The contrast is subtle, and their motion is measured. You can see how the sun reflects differently off these cloud tops, brightening the edges and casting soft shadows on the layers below. Each feature, while distant, carries the imprint of Saturn's energy, slow and patient, never rushed, always in balance. The space around Saturn is quiet, but not empty. Micrometeoroids drift past, too small to notice individually, yet their presence reminds you that even in silence, motion exists. Occasionally, a larger moon comes into view. Titan, the largest, moves slowly across the backdrop of the rings, its orange haze visible even at this distance. Its gravity slightly tugs at the ring particles nearby, creating small waves or ripples that are too subtle for the naked eye but can be measured scientifically. As you draw nearer, the light from Saturn becomes warmer, not like the harsh glare of the sun on Earth. It is filtered through layers of gas, creating a soft, glowing halo around the planet. Shadows deepen along the rings, and some parts reflect sunlight more brightly, highlighting the structure in subtle detail. You can imagine the vast distances between these rings and the planet, spaces larger than Earth itself, empty yet full of motion, a delicate system maintained by physics alone. From this position, you can sense Saturn's gravity without feeling it in the usual way. It bends the paths of nearby moons and pulls faintly at passing objects, shaping their orbits. The planet itself is less dense than Earth, but its size makes its gravitational influence strong. You could drop a small probe nearby, and it would fall slowly, spiraling toward the upper clouds, tracing invisible curves dictated by mass and distance. The rings begin to reveal more structure as you come closer. Some are dense and bright, others faint and thin. The Cassini division, a wide, dark gap, separates major ring bands. Though it looks empty, small particles still drift within it, hinting at the constant, patient motion of Saturn's system. The boundaries are not sharp, but the division remains clear. It is a record of gravitational interactions, showing the influence of moons like Mimas and others that shepherd the ring edges. You notice color changes in the clouds. Pale gold becomes richer near the poles, while the equatorial regions show softer shades. The light scatters differently in various layers, suggesting differences in particle composition and cloud thickness. Some clouds are ammonia ice, reflecting more sunlight and appearing brighter. Others carry trace compounds that darken their appearance slightly, adding subtle texture to the planet's face. Small vortices drift slowly along the bands. Each one rotates in place, spinning clockwise or counterclockwise, carrying with it faint streaks of clouds that slowly unravel and disappear into the surrounding atmosphere. These storms, though far away, show the energy and life of Saturn's weather system. You can watch them, noticing their size compared to the planet. Even the largest storms are small when measured against Saturn's totals surface area, yet they are enormous compared to anything on Earth. The shadows of the rings fall across Saturn's upper atmosphere, moving imperceptibly as the planet rotates. These shadows create subtle contrasts, long lines that trace the paths of particles above the clouds. Light and dark blend gradually, never harshly, giving the upper layers a soft, sculpted appearance. Sunlight reflects off ice grains in the rings, forming faint glimmers like distant stars circling the planet. The moons continue to move silently. Enceladus shows bright ice on its surface, glinting in the sunlight. Its position affects nearby ring particles in ways that can be measured by spacecraft. Even distant moons, like Rhea and Iapetus, contribute to the gravitational balance, nudging particles slightly and shaping the rings over time. This subtle interaction is constant, and yet it occurs without sound or hurry, a reminder of the patient scale of the cosmos. As you hold this view, Saturn's rotation becomes apparent. Though it completes a turn in just over 10 hours, the size of the planet makes motion slow to the eye. Bands shift imperceptibly, storms rotate, and cloud features gradually drift. You begin to sense the rhythm of the planet, a slow, steady pace unlike the hurried rotation of Earth. It feels deliberate, measured, and ancient. The upper atmosphere catches more light as you continue your approach. You notice small color gradients, faint hints of pink or pale brown within the gold. These are subtle changes caused by differences in chemical composition, the angle of sunlight, and the depth of the cloud layers. Light bends softly through the upper gases, creating a luminous halo that frames the planet and emphasizes its size. Even at this distance, Saturn exudes an almost physical presence. Its bulk is immense, yet the motion around it is gentle. You can follow the arcs of moons, the shifts in ring particles, the subtle flow of clouds, and feel connected to the system without moving yourself. It is a place of immense scale, yet it invites observation, slow and patient, offering detail to those willing to watch. Saturn's cold is absolute. There is no warmth here except for the faint sunlight, which does little to change the temperature. Hydrogen and helium in the upper atmosphere float freely, barely interacting. The density is low, yet the mass of the planet is enormous. If you could touch it, the pressure would be crushing, but from here you observe it safely, understanding its properties through sight and measurement alone. The rings continue to impress as you circle Saturn slowly. They have layers of varying thickness. Some sections are dense, appearing almost solid from this distance, while others are thin, nearly transparent. Gaps mark resonances with moons, where gravity has cleared paths or concentrated particles. The motions are all calculated by nature, obeying the laws of physics exactly. There is no noise, no disruption, only motion that is invisible unless you watch closely. Time seems to slow near Saturn. The planet's scale, the movement of its moons, the orbit of its particles, and the rotation of clouds create a rhythm that is slower than human perception. Observing it is a study in patience, learning to see motion that is measured and deliberate. The planet's gravity and rotation define a framework within which every object moves, each particle aware of its place without choice, responding only to natural law. Approaching the outer edge of the atmosphere, you can see the haze that marks the transition from empty space to Saturn itself. It is faint but present, a soft layer of gases that scatters light and prepares the eye for the colors below. This haze shields the deeper clouds and hints at what lies beneath, subtle layers that will reveal more detail as you descend. The first segment of the journey ends with a full view of Saturn in your field of vision. The planet fills the frame, its rings framing it like a delicate crown. The moons move slowly past, and the clouds show texture and motion. You feel the scale, the calm energy, and the silent rhythm of this world, knowing that the next stage will take you even closer into the atmosphere itself, where new details and experiences await. We move closer to Saturn's rings. At first, they appear as thin lines encircling the planet, delicate and soft against the dark background of space. As we near, the details become clear. The rings are made of countless particles, ranging from tiny grains of ice to larger rocks, each reflecting sunlight in its own way. Their motion is constant yet measured, Each piece follows a path around Saturn, orbiting in silence. No two particles collide often, but together they form a structured system that seems to stretch endlessly. Looking from above, the rings show subtle bands of light and dark. Some sections are thick with ice, bright and reflective. Others are faint, almost invisible from this distance, carrying more dust than solid material. Within the bright areas, smaller gaps appear. These gaps are not empty. They are places where Saturn's moons influence the particles, pulling some away, pushing others into denser bands. Each gap tells a story of gravity, invisible yet precise. The largest gap, the Cassini division, is visible even from this distance. It is wide and dark, separating the A and B rings. The division is caused by the gravitational pull of Mimas, one of Saturn's smaller moons. Particles within this space are pushed into new orbits, leaving a clear path between the rings. Despite appearing empty, tiny particles still drift within it, moving slowly and quietly. The division highlights the complex interaction between the planet, its moons, and the rings themselves. As we glide along the outer edges, the rings reveal more texture. Some areas sparkle with sunlight, giving the illusion of fine dust floating in space. Others are muted, with shadowed tones that suggest a mix of rock and ice. Even in the darker regions, the motion of particles is smooth. Each fragment is caught in Saturn's gravity, moving in loops that are repeated countless times every day, unnoticed by the eye but consistent in space and time. The rings are not flat. Their thickness varies, often only a few tens of meters in some regions, but extending hundreds of meters in others. The vertical movements are slight but detectable. Waves ripple along the rings like ripples on water, though there is no water here. These ripples are caused by the influence of small moons embedded in the rings. As a moon moves, its gravity tugs at the nearby particles, lifting them slightly and creating subtle patterns that travel outward. In some places, the rings show bright arcs or clumps. These are temporary concentrations of particles held together by weak gravity. They shift slowly, spreading and reforming over time. These clumps are too small to see individually from far away, but the way light reflects off them gives hints of their existence. Over years and decades, scientists track these movements, studying how the rings change and evolve under the constant pull of Saturn and its moons. From this close view, the scale of the rings becomes apparent. They extend tens of thousands of kilometers from the planet, yet they are very thin. The thinness is remarkable. Despite the vast width, there is little depth. Most particles orbit in nearly the same plane, a flat disk shaped by gravity and momentum. The uniformity is perfect in its own way, each particle following the rules of motion without interruption. You can see gaps and waves in finer detail. Some gaps are tiny, caused by tiny moons or resonances with larger moons. The waves move outward slowly, like faint pulses, carrying particles along in subtle arcs. These motions are rhythmic, almost like breathing, but they are determined entirely by forces and physics. Observing the rings in this way is to watch time in action. Each particle moves not by choice, but by natural law, yet together they create patterns that feel alive. Shadow and light play across the rings constantly. Parts closest to the sun reflect more light, brightening rapidly, while parts in shadow appear muted. At times, light from Saturn itself glances off the rings, creating faint glimmers on the darker bands. Those reflections change as the planet rotates. The shifting light reveals the structure of the rings, helping to distinguish between dense and sparse regions, smooth areas, and those disturbed by moonlets. The ring's motion is orderly but complex. Particles closer to Saturn orbit faster, following Kepler's laws, while those further out move more slowly. This speed difference shapes the rings over time. Collisions are rare but possible, and when they occur, the fragments are absorbed into surrounding bands. The rings are a dynamic system, persistent, yet always adjusting, maintaining balance across vast distances. Within the rings, small moons are visible. Pan and Daphnis, for example, move within narrow gaps, acting as shepherds. They maintain the shape of the ring edges, keeping particles in line through their gravity. Watching these moons, you can see faint disturbances along the edges of the gaps. Ripples travel outward from the moons, slowly fading as they move along. Each moon is small compared to Saturn, yet its influence on the rings is significant, shaping motion with quiet authority. The composition of the rings is mostly water ice, with a small portion of rock and dust. The ice reflects sunlight, which is why some bands appear so bright. The darker regions contain more dust or smaller particles, which absorb light differently. Temperature across the rings is low, just a few tens of degrees above absolute zero, but the sun still illuminates each particle, creating subtle contrasts and colors. Looking at the ring's edge on, they appear nearly invisible. Their thinness is astounding when measured this way. From above, they stretch out like broad bands, but from the side, you see how fragile the system is. Despite their appearance, the rings hold billions of particles, each in constant motion, forming a complex and delicate structure that persists in space. The rings extend outward from Saturn for tens of thousands of kilometers. They are divided into sections. The D, C, B, A, F, G, and E rings, each with its own characteristics. The A and B rings are the brightest and densest. The F ring is narrow, twisted, and braided, influenced by nearby moons. These divisions are visible from space, marking a map of orbital patterns and gravitational interactions. As we pass over the rings, the view changes. From above, the gaps are clear, arcs shimmer in sunlight, and clusters of particles reveal subtle differences. The rings are not uniform. Variations in density, size, and composition create textures that are intricate and complex. The motion of the particles continues, gentle yet constant, obeying the laws of physics without interruption. Occasionally, we see bright streaks caused by collisions between larger chunks of ice. These collisions throw smaller particles outward, forming temporary trails that fade over days or weeks. They are rare events, but they remind us that the rings are not static. They are alive with movement, even though it is slow and imperceptible without careful observation. The gravitational influence of Saturn and its moons keeps the rings stable. Resonances between moons and ring particles prevent the system from dispersing. Over centuries, this balance persists. Each particle has a place, moving along its orbit, subtly nudged by nearby moons, and maintaining the shape of the rings as a whole. As we circle Saturn, the colors of the rings become more apparent. Ice reflects sunlight in white and pale blue, while dust and rock show brownish tones. These variations are faint but visible against the blackness of space. The rings seem to pulse gently, though it is only the result of sunlight and shadow not motion in time. The ring's edges cast soft shadows on Saturn itself. From certain angles, these shadows stretch across the upper clouds, forming dark lines that shift slowly as the planet rotates. The play of light and shadow emphasizes the three-dimensional nature of the system. The rings are not only wide, but slightly thick, rising and falling in subtle undulations caused by embedded moons. Even at this stage, it is clear how fragile the system is. Tiny changes in orbit or composition could alter the rings over long periods, yet they remain stable, a testament to the balance of gravity and motion. Observing the rings from close range, you understand the precision required for such a structure to persist, moving in harmony with Saturn's gravity and the pull of distant moons. Time passes differently here. The particles move in constant orbits, completing circuits in hours or days depending on distance from the planet. Collisions are rare, yet the system absorbs disturbances gracefully. Each particle has a trajectory, and the sum of all trajectories creates a disk that seems alive, yet it is guided entirely by physics. We begin our descent into Saturn's upper atmosphere. From this distance, the planet no longer seems distant or untouchable. The bands of clouds start to show detail, revealing subtle textures and soft movements across the planet's face. The upper layers are mostly hydrogen and helium, like gases that form the majority of Saturn's atmosphere. Mixed within these are traces of methane and ammonia. These compounds create slight color differences in the clouds, adding faint blues, whites, and soft yellows that shift gently as we move closer. The clouds themselves are layered. Above, the light reflects off thinner ammonia ice clouds, forming brighter streaks against the deeper, denser layers. These layers move at different speeds. Winds blow in bands that circle the planet, faster near the equator and slower toward the poles. The motion is visible as subtle streaks, a hint of movement that requires careful observation. Some areas rotate in long, narrow jets, forming straight or slightly curved lines across the face of Saturn. One of the most remarkable features is the hexagonal jet stream at the North Pole. From above, it looks like a large geometric pattern, six-sided and stable for decades. Its edges are not perfectly straight, but remain sharp and distinct. The shape is caused by differences in wind speed and the planet's rotation. As we approach, we can see the clouds inside the hexagon swirl, moving slowly around the center. It is a quiet, measured motion, unlike storms closer to the equator. Clouds near the equator move more rapidly. They form bands that stretch across the planet, twisting and turning in complex patterns. Within these bands, small storms appear. They can last for days or weeks, depending on size and intensity. Some storms are white, reflecting sunlight from high ammonia clouds. Others are darker, showing the influence of deeper layers or trace compounds that change their color. The contrast between clouds is subtle, never sharp, but enough to reveal the dynamic nature of the atmosphere. We notice that clouds are not smooth. They have texture, like folds or gentle ridges formed by currents and convection. Rising gases push upward, cooler gases sink. This movement is slow but consistent. Light reflects differently off these textures, creating subtle highlights and shadows. Shadows are faint, soft, yet they reveal the depth of the layers. Looking closely, we see how clouds interweave, some drifting over others, some stretching along wind paths, forming patterns that repeat across the planet. High altitude winds shape the clouds in ways that are sometimes surprising. They curve and bend the layers, creating waves that ripple across the upper atmosphere. These waves are slow moving, often spanning thousands of kilometers. Their speed is modest compared to lower storms, yet their effect on the cloud patterns is significant. The result is a complex network of light and shadow, texture, and flow that shifts continuously as Saturn rotates. Occasionally, small bright storms appear as dots or streaks. These are areas of rising gas where ammonia ice condenses and reflects sunlight. Some appear isolated, while others form chains along the banded winds. Observing them, you can see the gradual expansion and dissipation, a quiet cycle of growth and fading. Their movement is gentle, drifting with the surrounding winds, yet they reveal the power and energy of Saturn's atmosphere on a scale far larger than Earth. Color changes are subtle but continuous. Clouds reflect light in ways that vary by altitude and composition. Higher ammonia clouds appear whiter, often tinged with pale yellow. Deeper layers show darker brown or muted gold. Small differences in methane concentration introduce faint blue tones in shadowed areas. Sunlight scattered through these layers creates a soft glow, illuminating edges and revealing the depth and separation of each cloud layer. The movement of the clouds is not chaotic. Each layer follows the laws of fluid dynamics, shaped by wind, rotation, and gravity. Bands flow alongside one another, some faster, some slower, creating shear zones where clouds interact. At these boundaries, waves and swirls form. They stretch for thousands of kilometers, moving steadily. Observing them gives the impression of a living system, though it is entirely natural, governed by predictable forces. Descending further, the clouds thicken. The top layers are soft and reflective, but below, denser ammonia and water clouds begin to appear. The color shifts become more muted, with shades of brown and gray interspersed with the gold and white above. The textures change as well, becoming more compact and layered. Each movement is slower, heavier, influenced by the higher pressure of deeper layers. We can sense the scale of these systems. Individual storms are immense, larger than entire continents on Earth. Bands stretch across the planet, wider than oceans. The jets that curve along the surface of the clouds carry tremendous energy. Yet from this perspective, everything moves at a measured, patient pace. There's no sudden motion, no abrupt change, only the continuous, calm flow of gases shaped by Saturn's gravity and rotation. High-altitude winds often collide at band boundaries. Where fast-moving equatorial winds meet slower polar streams, clouds twist and fold. This creates subtle eddies and vortices. They spin for hours or days, gradually stretching and fading into the surrounding atmosphere. Observing them, we see how energy moves through the system, transferring slowly from one region to another, maintaining the balance of the planet's circulation. The hexagonal pattern at the North Pole is accompanied by smaller, circular storms around it. These secondary storms drift slowly along the edges of the hexagon, occasionally merging or breaking apart. Their motion is steady, predictable in its own way, yet each event is unique, shaped by local conditions. Sunlight plays across these storms, highlighting the curvature and creating soft gradients in color. Clouds also carry evidence of chemical activity. Ammonia ice forms the highest, brightest layers. Methane absorbs red light, giving subtle blue shading in certain areas. Deeper layers contain heavier compounds, including water ice mixed with other elements, which contribute to darker tones. Each layer interacts with sunlight differently, producing a visual depth that is subtle but measurable. Descending through the upper atmosphere, we pass into regions where sunlight penetrates less. Colors darken, yet patterns remain visible. Bands continue to curve and flow. Storms drift along predictable paths, and waves ripple slowly through the cloud layers. The interplay of light and shadow shows the height and thickness of each layer. The transition from bright upper clouds to deeper muted layers is gradual, seamless, and continuous. Storms at lower altitudes are larger and more energetic. Their tops as break through higher clouds, reflecting sunlight while their bases remain hidden. Rising gases push upward, condensing into ice crystals, forming small white caps that drift with the wind. The contrast between these features and the surrounding bands creates a pattern that is both intricate and subtle. The motion is observable but slow, giving the impression of a calm, breathing planet. The atmosphere also carries faint waves that travel across bands. These waves are invisible unless observed closely, yet they influence cloud shapes and flow. The ripples can stretch for hundreds or thousands of kilometers. Each moves in harmony with surrounding clouds, transferring momentum gently. Watching them unfold, we sense the measured rhythm of Saturn's upper layers, a slow, deliberate motion that defines the character of the planet. Even minor storms reveal complexity. Some rotate clockwise, others counterclockwise. They drift across banded winds, stretching or compressing depending on local flow. Their brightness varies with height and composition. Observing multiple storms at once shows patterns of motion across thousands of kilometers, a network of activity that is constant but never chaotic. The descent continues gently. We move from soft, reflective clouds into thicker layers where motion is slower but more powerful. Winds continue to sculpt bands, storms rotate, and the texture of clouds changes with altitude. Each layer has its own speed, its own pattern, yet all are connected. Sunlight filters down through the gases, illuminating the clouds in soft, shifting tones. At the edge of the upper atmosphere, we see the transition to the lower layers. Light becomes more muted, colors blend together, and textures appear heavier. Storms are visible as faint rises in the cloud deck, hints of activity below. The bands continue, wide and flowing, stretching across thousands of kilometers, a testament to the steady power of Saturn's winds and rotation. The journey through the upper atmosphere leaves a sense of scale and depth. Bands, storms, and hexagonal patterns create a complex system moving slowly and gracefully. The gases flow according to predictable physics, yet the visual effect is rich and detailed. Every movement, every swirl, reflects forces beyond the eye, yet understandable through careful observation. Descending further from here, we will enter deeper, denser layers where the atmosphere becomes heavier and storms grow larger. The light diminishes, color shifts, and textures gain volume. The rhythm of Saturn's atmosphere will continue, slower but persistent, guiding our observation deeper into this giant breathe-in world. As we descend deeper into Saturn's atmosphere, the cloud layers begin to move more noticeably. Here, storms dominate the landscape, massive systems that dwarf anything on Earth. The air is thick with hydrogen and helium, carrying trace compounds that form subtle colors and textures. Some regions are calm, but others are alive with swirling motion. These storms rotate in tight circles, stretching clouds into long curved bands. Each storm is contained within the banded winds, yet each carries its own energy and character. One of the most remarkable phenomena in this region is the Great White Spot. This seasonal storm appears roughly every 30 Earth years, covering millions of square kilometers. From above, it looks like a bright patch on Saturn's surface, white against the surrounding golden clouds. The storm grows steadily, forming waves and spirals as rising gases push ammonia ice high into the atmosphere. Its scale is immense. The area affected is larger than the entire Earth. Observing it from close range, you can see the edges curl and break into smaller vortices, each rotating independently yet following the overall motion of the storm. The clouds within these storms move quickly, much faster than the surrounding winds. Jet streams carry them along curved paths, creating twisting patterns that shift slowly as Saturn rotates. Winds can reach speeds of over 1,800 kilometers per hour near certain bands, far exceeding anything on Earth. This speed, combined with the planet's size, stretches clouds into long, flowing shapes. The swirling motion is constant, a slow dance guided by gravity and the rotation of Saturn itself. Storms interact with one another in subtle ways. When two systems approach, they do not collide violently, but influence each other gently. Cloud bands bend and shift, merging or separating depending on wind direction. Smaller vortices spin around larger storms, forming chains or clusters that stretch for thousands of kilometers. The patterns are intricate, yet consistent with the principles of fluid dynamics. Each movement, no matter how subtle, reflects the forces shaping the atmosphere. Lightning sometimes occurs within these storms, though it is not visible from great distances. The electrical discharges generate faint flashes within the clouds, illuminating textures and revealing hidden layers. These flashes are brief, but they highlight the depth of the storm system. They also remind us that Saturn is not a quiet planet. Energy flows through its atmosphere constantly, shaping clouds, driving winds, and sustaining long-lasting storms. Seasonal changes affect the storms as well. The Great White Spot is strongest in northern summer, when sunlight warms the upper atmosphere and triggers convection. Rising gases carry ammonia ice upward, forming bright tops that reflect sunlight. As the storm grows, it moves with the banded winds, stretching across the planet's face. The surrounding clouds adjust, bending and swirling in response. The motion is complex, yet gradual, a slow unfolding of energy across thousands of kilometers. Clouds within the storms rotate in different directions depending on latitude. Near the equator, rotation aligns with the planet's spin. At higher latitudes, rotation can oppose the overall motion, creating subtle shear zones where clouds twist and fold. These zones produce long streaks and subtle spirals, often hundreds of kilometers across. Watching them, you notice how energy transfers from one band to another, maintaining balance in the atmosphere over long periods. Some storms rise above the surrounding clouds, forming isolated towers of ice. These towers catch sunlight differently, appearing brighter and casting faint shadows on lower layers. As they drift along the winds, they stretch into elongated shapes. The base of each tower remains in deeper layers, where pressure is higher and motion is slower. This vertical structure is a signature of the convection driving Saturn's weather, a slow movement of gases and energy that shapes both small storms and massive systems like the Great White Spot. Storms also leave traces as after they pass. Clouds behind the main vortex become stretched, forming long arcs that gradually fade into surrounding layers. The atmosphere adjusts slowly, filling gaps left by moving storms and restoring the banded pattern. These subtle changes are constant, a quiet cycle of growth, motion, and decay that continues uninterrupted. Even when no large storm is present, the atmosphere carries hints of past activity, visible as faint swirls and streaks across the bands. The winds themselves are fascinating. Jet streams circle the planet at different speeds, forming boundaries between bands. Some bands move faster than 1,500 kilometers per hour, while others drift more slowly. The differences create turbulence at their edges, lifting clouds, twisting storms, and producing waves that ripple through the atmosphere. The motion is continuous, a slow transfer of momentum that shapes the visual patterns of clouds we see from above. We can observe storms at various scales. Some are compact, with tight circular rotations only a few hundred kilometers wide. Others stretch across thousands of kilometers, forming ribbons of swirling clouds that snake across bands. The size of each system is proportional to the energy driving it, yet even the smallest vortices carry enough force to reshape clouds locally. The combination of scale and energy gives Saturn's atmosphere a richness that is subtle yet immense. The Great White Spot is often accompanied by smaller storms nearby. The secondary storms form as rising gases push into adjacent bands, creating bright streaks that twist and curve. Their motion is slower than the main storm, but their effect is measurable. They influence wind speed locally, bend cloud paths, and produce faint waves in the surrounding atmosphere. Together, they form a network of interconnected activity, all following predictable laws of motion. Observing the storms over time, we notice that patterns repeat. A vortex may form, stretch, and dissipate, only to be replaced by another in a similar location. The banded winds maintain this rhythm, guiding clouds along established paths. Even irregular storms follow the general flow of the atmosphere, a reminder that Saturn's system is organized by the planet's rotation and gravity. Cloud colors vary within storm systems. Bright white tops reflect sunlight from ammonia ice. Deeper layers appear pale brown or muted gold, depending on chemical composition and altitude. Shadows form along edges of vortices, emphasizing depth and motion. Sunlight scattered through the upper clouds creates soft gradients, highlighting subtle differences between layers. This interplay of light, color, and motion gives Saturn's storms a visual complexity that is quiet yet captivating. Some storms rotate rapidly around their own center. The cloud bands spiral inward, forming tight circles that can last days or weeks. These rotations interact with surrounding winds, creating eddies and waves that spread outward. Energy transfers gradually, shaping nearby clouds and adjusting wind speed. Observing these motions, we can see how Saturn's atmosphere balances energy across vast distances without chaos. Lightning flashes illuminate parts of storms occasionally. The flashes reveal textures hidden in shadows and highlight vertical structure. They are brief but powerful, a visual signature of energy moving through Saturn's gases. The presence of lightning shows that even in the slow, measured motion of the atmosphere, intense forces operate locally. Each flash is a small marker of the immense scale of energy in Saturn's storms. Storms produce faint ripples in surrounding clouds. These ripples propagate outward for thousands of kilometers, slowing as they move away from the main vortex. They influence cloud alignment, create streaks, and subtly change wind direction locally. The result is a dynamic, interconnected atmosphere where motion in one area gradually affects regions far away. Observing these effects helps us understand the energy flow and balance across Saturn's upper layers. The vertical structure of storms is important. Rising gases carry ice and other compounds upward, forming visible cloud tops. Below, gases are denser and move more slowly. This vertical layering contributes to the visual patterns we see and to the mechanics of the storm itself. Energy moves from lower to upper layers, sustaining rotation, feeding new vortices, and maintaining the overall banded appearance of the atmosphere. Even small disturbances can trigger changes in cloud flow. A localized increase in upward motion forms a bright spot that drifts with the wind. The spot stretches into streaks, sometimes joining larger systems or fading quietly. Each event is predictable in motion, yet unique in appearance. The complexity arises from the combination of rotation, wind, chemical composition, and gravity, all acting together in a measured, deliberate way. As we observe from above, the storms form a network across Saturn's face. Each system is connected by surrounding winds, subtly influencing others. The result is a planet in constant motion, yet the motion is slow, steady, and comprehensible. Even as new storms form and old ones dissipate, the overall banded pattern of the atmosphere persists, a quiet rhythm maintained over decades. Descending further into these layers, the clouds become thicker, more energetic, and more structured. The Great White Spot and other large storms reveal their full scale, showing rotation, vertical structure, and interaction with winds. The surrounding atmosphere adjusts in response, stretching, twisting, and curling into patterns that reflect both energy and balance. Observing these systems closely, one can feel the magnitude of Saturn's atmosphere, immense and patient, always moving yet calm from a distance. As we rise from the upper clouds toward Saturn's poles, the influence of its magnetic field becomes more apparent. Saturn has a strong magnetic field, shaped by the movement of metallic hydrogen in its interior. This invisible force extends far into space, surrounding the planet in a protective bubble called the magnetosphere. Within this bubble, charged particles from the planet and the solar wind are guided along magnetic lines, moving in arcs that eventually reach the poles. The magnetosphere is enormous, stretching millions of kilometers into space. It shapes the motion of particles around Saturn and protects the planet from high-energy radiation from the Sun. From this vantage point, we can observe how the charged particles follow curved paths, tracing invisible lines of force. These particles are primarily electrons and protons, and their motion creates a flow that interacts with the upper atmosphere, producing visible light in the form of auroras. Auroras appear as glowing bands around the poles. At Saturn, these lights are usually pale blue, white, or green, though they can shift depending on particle energy and atmospheric composition. They form rings that follow the magnetic field lines, encircling the pole in loops. The auroras are not constant. They pulse and shimmer as the incoming solar wind varies in speed and density. Observing them closely, you notice movement that is slow but rhythmic, a quiet dance of light across the upper atmosphere. The northern and southern auroras have subtle differences. The northern lights often form more defined arcs, while the southern can appear broader, more diffuse. Both respond to the solar wind, which pushes particles into the magnetosphere. These collisions excite gases in the upper atmosphere, primarily hydrogen, causing them to emit faint light. The effect is visible even from space, though subtle, a soft glow that traces the invisible structure of the magnetic field. Sometimes, bright flares appear within the auroral rings. These flares result from sudden increases in particle flow, creating temporary bright spots that drift slowly along the field lines. Their motion is steady, following the curve of Saturn's magnetic field, and they fade gradually. Watching these events, you notice how the aurora reacts to forces far beyond the planet itself, a response to solar activity millions of kilometers away. The auroral glow is layered. At higher altitudes, light is brighter and sharper, reflecting collisions with faster moving electrons. Lower layers emit softer light, diffused through hydrogen and helium. The result is a three-dimensional structure, a gentle halo that pulses with subtle intensity. Shadows from higher layers play across the glow, adding depth and texture. The visual effect is constant, yet ever-changing, a slow rhythm that invites careful observation. Auroras also move with Saturn's rotation. As the planet turns, the magnetic field lines rotate with it, carrying auroral features along. This rotation creates sweeping motions that trace long arcs across the poles. Observing these arcs, you can see faint streaks and ripples, patterns created by local variations in particle density and magnetic strength. Even small differences in the solar wind produce visible changes, stretching the auroral shapes or causing faint flickers along the rings. The magnetosphere itself is filled with charged particles from both Saturn and the solar wind. These particles are trapped along field lines, spiraling back and forth between the poles. Occasionally, they collide with gas in the upper atmosphere, producing the auroral light we see. The process is constant, creating a soft, persistent glow at the poles. From space, the effect is quiet, yet the underlying energy is immense. From a sensory perspective, the auroras suggest motion beyond sight. If imagined as faint sound, the pulses of light might resemble slow hums or soft vibrations, continuous and gentle. The movement of particles along magnetic lines is steady, smooth, and invisible, but their effects create visual cues that the eye can follow. Observing the auroras, you sense the connection between Saturn, the solar wind, and the vast space around the planet. The auroral ovals are not perfectly circular. They shift slightly depending on solar wind pressure and local magnetic fluctuations. Some sections are brighter, where particle density is higher, while others appear fainter, stretching and bending with the forces at work. Despite these changes, the overall shape remains a ring, emphasizing the structure of Saturn's magnetic field and its role in shaping the auroral display. Solar wind interacts with the magnetosphere at the day side, compressing it slightly, while the night side stretches into a long tail. This tail is filled with flowing charged particles, moving slowly outward from the planet. Occasionally, bursts of solar wind from the sun send waves through the magnetosphere, causing auroras to brighten or pulse. These variations are subtle yet continuous, a gentle reminder of the forces acting far beyond the clouds we have observed below. The auroras also carry a faint energy that is measurable. Charged particles spiral along the field lines at high speed, creating electromagnetic effects. Though invisible to the eye, these effects influence nearby particles and can be detected by instruments. The combination of particle motion, magnetic forces, and atmospheric interaction forms a system that is continuous, flowing, and predictable, yet always slightly shifting in response to external conditions. Watching the auroras from close range, you can see fine filaments within the glowing bands. Those filaments stretch along the magnetic lines, sometimes appearing to twist or wave. They result from differences in particle energy and density, subtle changes that highlight the complexity of Saturn's magnetosphere. Even at a calm, observational pace, the aurora shows dynamic structure on a scale that dwarfs human experience. The southern aurora mirrors the north in many ways, yet it has distinct features. Its bands are often broader and more diffuse, spreading light across a larger area. Some arcs are faint and irregular, responding to local magnetic variations. Observing both poles simultaneously reveals symmetry in the system, shaped by the underlying magnetic field, yet nuanced in detail. Charged particles interact with Saturn's moons in subtle ways. Enceladus, for example, emits a plume of material from its surface. This plume enters Saturn's magnetosphere, adding particles that flow along field lines. Some reach the auroral regions, contributing faintly to the brightness. The interaction between moons, magnetic field, and atmosphere is gentle but constant, a reminder of the interconnectedness of the Saturnian system. Auroral motion is slow but perceptible. Bands drift gradually, pulses of brightness ripple along their lengths, and small flares appear and fade. The movement is smooth, rhythmic, and predictable in its own way. Observing it over time provides a sense of Saturn's scale and the quiet, measured energy that defines this environment. Even the darkest regions between auroral arcs are filled with subtle activity. Particles must spiral along unseen lines, occasionally colliding with trace gases. The light from these collisions is faint, often lost in the stronger glow of the main auroral bands, yet it adds depth and complexity. Over time, the auroral display reveals patterns that are constant, subtle, and structured. From above the poles, Saturn's auroras are framed by the dark space beyond. The contrast emphasizes the glow, making the pulsing light more visible. Reflected light from the upper clouds adds a soft halo around the arcs. The effect is not bright in an overwhelming sense, but gentle, guiding the eye along curves and contours that follow the magnetic field lines. The magnetosphere also shapes the motion of the solar wind around Saturn. The planet acts like a shield, redirecting high energy particles along field lines and preventing most from reaching deeper layers of the atmosphere. Observing the interaction from above, you can see the smooth deflection, the gentle bending of particle streams as they curve around the magnetic bubble. This motion is constant, silent, and invisible without measurement, yet it defines the shape and behavior of the auroras below. Auroral brightness varies with particle energy. High energy electrons create more intense light, while slower particles produce faint illumination. The pulsing glow reflects the ebb and flow of these energies, producing a rhythm that is continuous yet never repetitive. Each observation reveals something slightly different, a small shift in intensity, shape, or pattern that reminds us of the complexity of the magnetosphere. From this vantage, the connection between Saturn, its atmosphere, and the surrounding space becomes clear. The auroras are a visual indicator of forces invisible to the eye, a map of charged particle motion guided by gravity, magnetic fields, and solar influence. Observing them is to witness energy flowing through a system larger than the planet itself, yet contained by natural law. The auroras persist even as the planet rotates. Bands follow the field lines, shifting slowly, pulsing with subtle brightness. The visual effect is hypnotic, calm, and steady. It invites quiet observation, drawing attention to the scale, motion, and energy of Saturn's polar regions without requiring action or explanation. Watching them, one can sense the depth of the planet's magnetic environment and its continuous interaction with the sun and space around it. As we move away from the poles, the auroras fade gradually. Their glow diminishes with distance from the magnetic lines, yet the energy remains in the magnetosphere, flowing along invisible paths. The faint pulse continues like a heartbeat, reflecting the steady motion of charged particles and the ongoing influence of the solar wind. Even as light fades, the effect of the magnetosphere is constant, a quiet, measured presence surrounding the planet. As we move outward from Saturn's atmosphere, the first of its moons comes into view, Titan. Titan is the largest moon, larger than the planet Mercury. Its surface is hidden by a thick orange haze, an atmosphere composed mainly of nitrogen with traces of methane. From a distance, the haze glows softly in sunlight, creating a diffuse, warm outline. Flying past Titan, we notice its round silhouette against the background of space, slowly rotating as it orbits Saturn. Shadows from the moon stretch across the rings. Below, faint lines of darkness that shift as both the moon and the planet turn. Titan's atmosphere is dense and extends far from the surface, creating a soft gradient between moon and space. Light filters through the haze, scattering in subtle ways that reveal gentle changes in density and composition. Below the clouds, the surface is cold, with lakes and rivers of liquid methane and ethane. Though hidden from view, the knowledge of these liquids shapes the way we understand Titan. Winds move through the upper atmosphere, shaping clouds that drift in slow, silent motion. The rotation of Titan and the orbit around Saturn create tiny variations in shadow and light, producing gentle shifts in brightness that can be observed during the flyby. Beyond Titan, Enceladus comes into view, smaller but strikingly bright. Its surface is coated in clean white ice, reflecting sunlight almost completely. Cracks in the ice, known as tiger stripes, release jets of water vapor and ice particles rising from the surface and forming faint plumes that extend hundreds of kilometers into space. Flying close, we see the plumes gently bend under the influence of Saturn's gravity. The particles drift outward, some falling back to the surface, others joining the planet's E-ring, contributing to its faint glow. Enceladus rotates slowly, allowing observation of different surface features. Impact craters dot the landscape, some shallow, others deeper, hinting at a history of collisions. The ice is fractured, forming ridges and valleys that stretch across the moon. Though the surface is frozen, the plumes reveal active processes beneath, driven by a subsurface ocean warmed by tidal forces from Saturn. Observing the motion of particles in the plumes, We sense the subtle influence of gravity as they curve along predictable arcs. Continuing outward, Rhea becomes visible, a smaller moon with a surface marked by crater impacts. Rhea has no thick atmosphere, leaving the surface exposed to direct sunlight. Shadows from craters and ridges stretch across the icy terrain, creating a gentle texture that is visible even from a distance. The brightness of Rhea contrasts with the darker background of space and the muted tones of Saturn's rings. Its rotation is slow and orbit steady, creating predictable patterns of light and shadow that shift gradually over time. Iapetus lies further beyond, its two-toned surface striking from afar. One hemisphere is dark, coated in carbon-rich material, while the opposite is bright and reflective. As we pass, the contrast becomes evident, a division of light and dark that defines the moon's appearance. The two-toned surface is shaped by differences in composition and external dust, as well as the angle of sunlight. Slowly, we observe the subtle curvature of the surface and how shadows highlight ridges and valleys along the equator. Iapetus rotates in the same period as its orbit, presenting the same face to Saturn, a synchronized dance that is visible in its slow, steady movement. All of these moons exert subtle gravitational effects on Saturn and the surrounding rings. Titan, with its mass, causes small shifts in the positions of particles within the rings. Enceladus contributes material to the E-ring, shaping its distribution. Rhea and Iapetus create gentle tidal influences that affect the motion of other moons and ring particles. Flying past, we sense the interconnected nature of the system, the moons moving in harmony with the planet's rotation and orbital dynamics. The perspective of passing by these moons provides a sense of scale. Titan appears immense, with a hazy atmosphere and hidden surface features. Enceladus is smaller but active, plumes rising delicately from the icy crust. Rhea and Iapetus are more static, marked by craters and contrasting surface materials. Each moon casts a faint shadow across Saturn's rings, moving slowly with its orbit. Observing these shadows gives a tangible sense of motion and distance, a reminder of the slow, methodical rotations and orbits that define the system. The motion of particles near the moons is influenced by gravity. Material from Enceladus's plumes drifts outward, forming trails that eventually mix with the rings. Tiny dust particles from Titan and Iapetus orbit Saturn along their own paths, subtly affected by each moon's mass. The interaction is delicate yet persistent, a slow shaping of the system over long timescales. As we continue past the moons, Saturn itself fills the background. Its rings stretch across the field of view, illuminated by sunlight. The shadows of moons move along the rings, shifting gradually as both moons and rings rotate. Titan's shadow is faint but noticeable, while Enceladus casts a brighter, sharper line. Rhea and Iapetus produce more diffuse shadows, barely visible against the brightness of ring particles. Observing these interactions, we see the precise dance between moons, rings, and planet. The surface features of each moon provide additional detail. Titan's haze suggests hidden landscapes, lakes, and riverbeds. Enceladus's cracks and ridges reveal subsurface activity. Rhea's cratered terrain reflects impacts over millions of years. Iapetus's dual surface shows the effects of dust and sunlight on different materials. Each moon tells a story of composition, history, and interaction with Saturn's gravity and the larger environment of the rings. The flyby perspective also reveals the orbit paths. Titan orbits slowly, making a full revolution in 16 Earth days. Enceladus moves more quickly, completing its orbit in just over a day. Rhea takes about 4.5 days, while Iapetus takes nearly 80 days to circle Saturn. These orbital periods affect how shadows and gravitational influences shift over time. Observing the motion provides a sense of the rhythm of the Saturnian system, a slow, predictable cadence. The moon's surfaces reflect light differently. Titan's haze softens sunlight, producing a diffuse glow. Enceladus's ice is highly reflective, shining brightly in direct light. Rhea's surface reflects moderately, while Iapetus shows stark contrast between dark and bright regions. The effect is subtle yet noticeable, creating a visual texture across the moons and emphasizing the differences in composition. The tidal forces between Saturn and its moons influence more than just orbits. Enceladus's subsurface ocean is heated by tidal flexing, causing the plumes we observe. Titan's atmosphere is maintained in part by its size and distance from Saturn. Rhea and Iapetus experience less internal activity, yet their positions and gravity still shape the environment of smaller moons and ring particles. These forces are slow, continuous, and measurable over time, providing structure to the entire system. As we continue to fly past the moons, the scale of space becomes clear. Distances between moons are vast, yet they move in precise orbits dictated by gravity. The rings provide a background reference, stretching across tens of thousands of kilometers. Shadows, light, and motion combine to give a sense of the three-dimensional space surrounding Saturn. Observing the moons from this perspective reveals their individuality and their place in the larger planetary system. The motion of moons also subtly influences atmospheric patterns on Saturn. Titan's gravity, though small relative to the planet, contributes to tidal shifts that affect the upper layers of clouds and winds. Enceladus, Rhea, and Iapetus produce smaller effects, yet these interactions are constant. The atmosphere, rings, and moons form a connected system, moving in a slow, predictable rhythm governed by physics. From this vantage, the moons appear peaceful and steady. Titan drifts through its orbit, clouds hidden beneath haze. Enceladus releases plumes that bend gently under Saturn's pull. Rhea and Iapetus follow smooth elliptical paths, their craters and surface features reflecting sunlight in subtle ways. Each moon interacts with the environment, yet their motion is calm and orderly. Observing them, one senses the quiet, patient mechanics of the Saturnian system, a slow dance unfolding over thousands of kilometers and millions of years. Even as we move past these moons, the shadows they cast on Saturn's rings continue to shift. Titan's haze softens the shadow line. Enceladus produces a sharper outline. Rhea and Iapetus create faint, elongated shapes. The shadows drift slowly, tracing the moon's motion across the rings and providing a constant visual cue of orbit and scale. Each shadow emphasizes the interaction of light, mass, and distance in a tangible, observable way. Flying beyond Iapetus, the smaller moons appear in the distance. They are less massive, more irregular in shape, but they continue to orbit Saturn in precise paths. Their surfaces vary, some icy, some darkened by dust, some showing faint ridges or craters. The moons together create a complex system of orbits and interactions, all moving with a calm, measured pace. The influence of Saturn's gravity holds them in place, guiding them in a predictable rhythm that has continued for millions of years. Passing by these moons provides an immersive perspective on the Saturnian system. We see the scale, the motion, and the interactions. Shadows drift across rings. Light reflects from ice and haze. Particles move subtly under gravity. Winds on Titan shift clouds. Plumes rise from Enceladus. The orbiting moons remind us that Saturn is not a single planet in isolation, but a dynamic, interconnected system of bodies, each moving steadily in a slow, rhythmic ballet. We begin a slow descent into Saturn's lower atmosphere, moving beyond the upper cloud layers we observed earlier. The air grows denser as we sink, and pressure increases steadily. At first, the change is subtle, barely noticeable in movement, but gradually it becomes more evident. Molecules are packed closer together, and the atmosphere carries more weight. This density affects how clouds move, how light travels, and how the winds interact with one another. Temperatures rise as we descend. In the upper layers, the air is cold, but in the deeper layers, heat increases gradually, though it remains below the extreme temperatures of rocky planets. The combination of rising pressure and increasing warmth creates new behavior in the gases. Hydrogen and helium continue to dominate, but trace amounts of methane and ammonia react under these conditions, forming denser clouds and creating subtle changes in color and opacity. The clouds themselves shift in appearance. Colors become muted and heavier, blending from pale yellows and golds into soft browns and faint oranges. Patterns are no longer as smooth. They stretch, fold, and curl as deeper winds influence them. Jet streams carry clouds along curved paths, twisting them into shapes that hint at vertical motion beneath. Layers that seemed flat from above now reveal depth, rising and falling like gentle waves frozen in time. Pressure differences create gradients that influence motion. Higher pressure areas push against neighboring regions, while lower pressure zones allow gases to rise more freely. This interaction generates turbulence on a small scale, producing fine dynamic textures in the cloud layers. Observing from within, one senses subtle motion all around, a constant interplay of forces balancing in 3 dimensions. The deeper we descend, the dimmer the light becomes. Sunlight filters through thicker cloud layers, scattering and diffusing in ways that soften shadows and reduce contrast. The colors shift as a result. Bright whites fade into soft creams, and pale yellows darken into muted gold. Light moves more slowly, bending around cloud edges and reflecting off suspended particles. The atmosphere appears denser, visually as well as physically, a rich medium through which we pass slowly. Ammonia clouds form intricate shapes, rising and falling with gentle currents. Methane contributes to darker tones, pooling in pockets where rising and sinking gases meet. Layered textures become evident, revealing the stratification of the atmosphere. Each layer carries its own temperature, pressure, and chemical composition. Some are smooth, others textured with small vortices and fine ripples. The transitions between layers are gradual, yet distinct enough to notice subtle differences in density and color. Storm systems continue in these lower layers, though their shape is altered by pressure. Vortices stretch vertically as winds at different altitudes move at different speeds. Swirling clouds rise from lower regions, carrying frozen compounds upward. These motions feed higher layers, sustaining the patterns we observed above while adding complexity to the lower atmosphere. Light through these clouds casts gentle, moving shadows, emphasizing depth and motion without brightness or glare. Chemical interactions play a subtle role in shaping the environment. Ammonia reacts with other compounds to form icy particles that float slowly upward or settle downward. Methane combines under pressure with hydrogen, producing clouds that appear thicker and slightly darker. These reactions are constant but gradual, contributing to the layering and textural variety of the lower atmosphere. Observing closely, one can see how these processes maintain balance within the system. The stratification of Saturn's atmosphere is clear here. Upper layers are less dense, dominated by thin clouds and gentle winds. Middle layers carry more turbulence, larger vortices, and moderate pressure. Lower layers are dense, warm, and highly dynamic, with complex chemical activity. Each layer interacts with the others, transferring energy and shaping the movement of clouds and gases. Observing these interactions provides insight into how the atmosphere sustains long-term patterns, from jet streams to storms. As we descend further, the curvature of the cloud layers becomes more apparent. Layers rise and fall in gentle arcs, following the forces of gravity and rotation. Some sections form depressions, where gases sink and cool. Others rise in gentle plumes, carrying particles upwards. The visual effect is dynamic, yet slow, a quiet unfolding of structure within the thickening atmosphere. Temperature gradients are measurable and consistent. Each increase in depth brings a steady rise in heat. The upper layers remain cold, but by the time we reach mid layers, warmth is more noticeable. The effect on chemical composition is significant. Gases respond to temperature differences, expanding or contracting, altering density, and influencing cloud formation. Observing these gradients gives a sense of the physical structure beneath the clouds. Winds at these depths vary significantly. Jet streams at lower levels move more slowly than those above, but they remain strong enough to shape the formation of clouds. Vertical winds rise from high pressure zones and sink in low pressure regions, creating fine scale turbulence. Smaller vortices spin within larger patterns, interacting subtly but noticeably, producing motion that is continuous and structured rather than chaotic. Light continues to change. Diffused sunlight passes through the thickening clouds, highlighting subtle color differences and shadow patterns. Deeper layers block direct sunlight, casting soft, muted tones across the dense clouds. The interplay of shadow and color emphasizes depth and variation. Observing closely, one can see the contours of plumes, the edges of rising clouds, and faint motion within layers that appear stationary from above. The chemical composition of the lower layers contributes to a faint, almost imperceptible glow. Methane absorbs some sunlight, while hydrogen and helium allow light to pass more freely. Ammonia particles scatter light subtly, highlighting edges of clouds and plumes. These interactions are gentle, yet they create a dynamic, layered visual environment that feels alive despite its slow, steady pace. Descending further still, turbulence increases slightly. Winds move at varying speeds, causing clouds to stretch, fold, and twist in complex patterns. Smaller vortices appear within larger ones, forming intricate textures that evolve slowly over time. The motion is quiet and continuous, perceptible only by close observation, yet it maintains the stability of the overall system. The depth reveals denser clouds of ammonia ice. These clouds rise and fall in response to temperature and pressure differences. Pockets of denser gas create localized shadows and color shifts, forming subtle variations that break the uniformity of earlier layers. The effect is one of texture and depth, emphasizing the three-dimensional nature of the lower atmosphere. Observing chemical layering, we see how compounds interact. Methane tends to collect in cooler pockets, while ammonia ice rises in warmer regions. Hydrogen dominates overall, creating a fluid medium through which these reactions occur. The combination of elements, temperature, and pressure results in an atmosphere that is both stratified and dynamic, each layer influencing those above and below. Vertical motion of clouds continues slowly. Rising plumes carry particles upward, feeding higher layers and sustaining subtle turbulence. Sinking currents draw gases downward, compressing layers and creating faint shadows. The overall effect is a steady, continuous motion, visible only as gradual changes in texture and shape, yet essential to the balance of Saturn's atmosphere. As we reach even lower levels, the light dims further. Direct sunlight is almost entirely blocked by thick clouds. Remaining light filters through multiple layers, creating muted tones and soft shadows. Its colors shift to deep golden browns, with occasional hints of pale yellow or orange where sunlight penetrates gaps. Cloud layers appear more substantial, forming ridges, waves, and flowing structures that respond to both rotation and local winds. The motion is continuous but slow. Vortices and plumes rise and fall gently. Jet streams move particles along bands, stretching clouds into elongated shapes. Turbulence occurs subtly, creating fine texture without dramatic chaos. The atmosphere is dense, warm, and responsive, yet the pace remains calm, measured, and observable. Pressure here is significant. Each layer above exerts weight on the one below, compressing gases and influencing chemical interactions. Ammonia ice is denser, methane collects in pockets, and hydrogen flows through all levels. The balance of pressure, temperature, and composition shapes cloud structure and movement, creating a stratified environment that is both layered and interconnected. Descending further, we notice new textures. Clouds appear thicker, with soft ridges and valleys. Plumes rise slowly from lower pockets, carrying particles upward. Shadows play along the edges, emphasizing curves and folds. Colors are muted, blending golden browns with pale yellows and subtle grays. The effect is complex yet calm, a visual environment shaped by density, motion, and chemical composition. Temperature, pressure, and composition create dynamic equilibrium. Rising currents feed higher layers, sinking gases compress lower layers, and chemical reactions sustain subtle changes in density and color. The atmosphere is alive with slow, structured motion, each layer interacting with its neighbors. Observing from within, we feel the balance, a measured rhythm of movement that continues without abrupt change. The visual effect is immersive. Layers stretch above and below, plumes rise gently, vortices rotate slowly, and jet streams carry clouds in continuous motion. Light filters through, highlighting textures and depth. The lower atmosphere is dense, dynamic, and layered, yet movement is calm, controlled, and observable over time. As we continue to descend, the atmosphere becomes even more complex. Clouds fold, rise, and sink. Chemical reactions continue at subtle rates, shaping textures and color. Shadows and diffused light emphasize depth and structure. The motion is continuous and interconnected, reflecting the slow, persistent dynamics of a dense, stratified environment. We begin to sense the overall structure of Saturn's lower atmosphere. Upper layers are lighter and faster moving. Middle layers carry storms and moderate winds. Lower layers are dense, layered, and chemically active. Energy flows between layers, sustaining motion and balance. The patterns we see are both large scale and detailed, a continuous, connected system shaped by pressure, temperature, composition, and motion. As we move past the thick lower atmosphere, we begin to imagine what lies beneath, deep inside Saturn. Unlike the cloud layers we have passed, the interior is hidden from direct view, but science provides a clear picture. Beneath the upper gases, the planet becomes denser. Hydrogen is compressed into a liquid form, and under even greater pressure, hydrogen behaves like a metal. This metallic hydrogen is highly conductive and plays a key role in generating Saturn's magnetic field. We descend slowly, imagining the increasing pressure as we move inward. The gases above press down with immense weight. Temperature rises gradually, reaching levels far hotter than anything we have experienced in the cloud layers. The density of the material increases continuously, forming a layered structure. The outer layers are mostly hydrogen and helium gas. Beneath them, hydrogen turns liquid, becoming denser and more opaque. Deeper still, metallic hydrogen forms, creating a dense, electrically conductive layer that supports the planet's magnetism. As we approach the central regions, the core becomes the focus. The core is thought to be rocky, possibly mixed with ice and heavier elements. It is compact and extremely dense. Gravity increases steadily as we move toward the center, and the force pulls more strongly than we felt in the upper layers. The interior is hot, heated both by the pressure of overlying layers and by the slow release of energy from the formation of the planet. This heat flows outward, contributing to convection in the surrounding layers of metallic and liquid hydrogen. The change in density is gradual but continuous. Lighter gases compress first, followed by liquid hydrogen, then metallic hydrogen. Each layer bends light differently. Visual distortions increase as we pass through these dense materials. Light filtering from the upper layers is diffused, scattered, and sometimes refracted. The deeper we imagine going, the more subtle the visual cues become, replaced by understanding of pressure and density. The metallic hydrogen layer is particularly interesting. Its conductivity allows electric currents to form, which in turn generates Saturn's magnetic field. This process is slow and stable, creating a magnetic environment that extends far into space. Observing this layer, one imagines smooth motion of dense hydrogen, flowing gradually in currents shaped by rotation and pressure. The motion is continuous and steady, yet it sustains immense energy that influences the space around the planet. Temperature continues to rise with depth. From the cold upper clouds to the warmer lower atmosphere, and now into the metallic and liquid layers, heat becomes a constant presence. In the deepest parts, it can reach thousands of degrees. The combination of pressure and heat ensures that hydrogen remains in liquid or metallic form, compressed into layers that are stable yet dynamic. The heat slowly moves outward, carrying energy from the interior to the upper atmosphere, where it subtly influences cloud patterns and storms. The rocky core is dense and compact. It is thought to contain heavier elements, possibly silicates and metals, forming a solid center. The core's mass dominates the planet's gravitational pull, anchoring the layers above and influencing the orbits of moons and rings. Gravity is strongest here, pulling evenly from all sides. If one could observe the core directly, its surface would appear featureless, dominated by sheer density and heat. Surrounding layers flow around it, forming a structured interior that balances pressure, rotation, and composition. Internal convection is subtle yet continuous. Heat rises from the core through metallic and liquid hydrogen, creating slow, rising currents. These currents affect the surrounding layers, shaping density gradients and contributing to long-term atmospheric patterns. Energy moves outward steadily, reaching the upper clouds in a way that influences winds, jet streams, and storms. The interior is a slow engine, persistent and constant, providing power to the planet without visible drama. Density changes can be imagined as gradual compression. Hydrogen gas at the outer edge is light and expansive. Liquid hydrogen is dense and fluid. Metallic hydrogen is even denser, heavy, and opaque. The rocky core is compact, unyielding, and dominates the center of mass. Each layer transitions smoothly into the next, maintaining continuity and balance. The changes are not abrupt but progressive, forming a continuous structure from gas to metal to rock. Gravitational pull increases steadily. In the upper atmosphere, it is mild, just enough to hold clouds in place. Deeper down, gravity becomes stronger, pulling more forcefully on particles and gases. In the metallic hydrogen layers, the pull is significant, yet the fluid medium allows motion to continue without turbulence. The core exerts the strongest pull, anchoring the entire planetary structure. The effect on orbits, both of moons and ring, particles, is measurable and constant. Light within these layers behaves differently. Gases scatter sunlight. Liquid hydrogen absorbs and diffuses light. Metallic hydrogen bends some and distorts light, creating an almost impenetrable interior to direct observation. Shadows and reflections are subtle. Colors fade into muted shades, replaced by the understanding of density and pressure. The visual experience is dominated less by color than by the knowledge of structure, temperature, and energy distribution. The magnetic field originates deep within these layers. Electric currents in metallic hydrogen flow slowly yet persistently. They create a strong magnetic environment that extends far beyond the planet, guiding charged particles and shaping auroras at the poles. The field is stable, continuous, and aligned roughly with the rotation axis. Its presence is invisible to the eye, but defines much of the planet's interaction with its environment. Temperature gradients are important in maintaining convection. Heat rises from the core, carried by liquid and metallic hydrogen. Upper layers of gas and clouds absorb energy gradually. This slow movement of heat influences everything above, from the lower atmosphere to the clouds and storms we observed earlier. The interior is a quiet but powerful engine, maintaining energy flow that sustains the planet's dynamic systems. Density and pressure interact continuously. Heavier elements in the core exert force on surrounding layers. Metallic hydrogen flows around the core, responding to rotation and internal currents. Liquid hydrogen adjusts, balancing pressure and chemical composition. The upper gas layers respond to all these underlying forces, producing subtle motions, variations in cloud density, and wind patterns. Each layer is connected to those above and below, forming a unified, structured system. The descent toward the core also illustrates the scale of the planet. Each layer, from outer gas to metallic, interior to rocky center, occupies thousands of kilometers. The transition is gradual but immense. The combined mass of these layers accounts for Saturn's size and gravitational influence. The interior is continuous, interconnected, and slowly moving, yet utterly massive. As we imagine moving closer to the core, the gravitational pull grows stronger, the density becomes extreme, and temperature rises further. Layers above compress under the weight, and energy flows outward. Light diminishes, colors fade, and motion continues slowly in currents within metallic hydrogen. The planet's structure is maintained by rotation, composition, pressure, and temperature, forming a balanced, stable interior. Visualizing the interior, we imagine smooth layers of metal and liquid, currents flowing steadily. The core remains compact, dense, and hot. Gravity shapes every layer, maintaining stability. Energy flows outward, slowly, feeding the atmospheric patterns above. Magnetic field lines are anchored in the metallic hydrogen, generating the invisible envelope that extends across space. The interior is structured, continuous, and unbroken. The planet's internal heat is a persistent feature. It is generated both by the slow contraction of Saturn and by residual heat from formation. Heat rises steadily, moving through dense layers. It influences convection and the motion of metallic and liquid hydrogen. Energy eventually reaches the clouds, feeding subtle winds, storms, and jet streams. This continuous flow links the deep interior to the visible atmosphere, demonstrating the planet's internal coherence. The descent reveals the gradual changes in composition, density, and energy. Outer gas layers are light, easy to move through. Liquid hydrogen is denser and slower. Metallic hydrogen flows with continuity, carrying electrical currents. The rocky core dominates the center, compact and unyielding. Each transition is smooth, connected, and part of a single unified planetary structure. Saturn's rotation influences interior motion. Currents in metallic hydrogen are shaped by the planet's spin, forming bands and flows aligned with rotation. Convection occurs more easily along these paths, feeding the magnetic field and subtly influencing the motion of outer layers. The internal movement is slow, controlled, and steady, yet it sustains the magnetic field that shapes the auroras and protects the planet from solar wind. Gravity, density, and internal energy combine to create a balanced system. Each layer supports those above it, reacts to those below, and flows in a manner dictated by physics. The metallic hydrogen, liquid hydrogen, and rocky core together form a coherent interior that maintains the shape, rotation, and energy flow of Saturn. Even without direct observation, the behavior of the planet's atmosphere, rings, and magnetosphere confirms the structure and dynamics of its interior. As we imagine the journey near the core, we sense the scale, weight, and energy. Pressure is immense, temperature rises, and motion continues. The interior is layered, dynamic, and stable. Metallic hydrogen flows, currents generate the magnetic field, and energy moves outward to the atmosphere. The rocky core anchors all layers, providing structure and stability. Observing this, one can appreciate the balance of forces that defines Saturn's interior. As we move away from the core and lower atmosphere, we begin to feel Saturn's gravity in a new way. Not in the sense of being pulled down like on Earth, but as a constant presence that shapes the motion of everything nearby. The planet's mass creates a field that extends far beyond the clouds and rings, influencing moons, particles, and even spacecraft that pass close by. Floating in this environment, one senses subtle accelerations, gentle pulls that shift direction slowly as we move along with the planet's rotation. Saturn's gravity holds its moons in precise orbits. Each moon moves at a speed dictated by its distance from the planet. Titan, the largest moon, orbits more slowly, while smaller moons like Enceladus or Dione move more quickly. The effect of gravity is clear in their motion. The pull is balanced by the centrifugal effect of their orbit, keeping them from falling into the planet. Observing this, one can feel the harmony of motion, the invisible hand of Saturn maintaining order across the system. Tidal forces are subtle but constant. The gravity of Saturn stretches and compresses its moons slightly as they orbit. On Enceladus, for example, this tidal flexing generates heat inside the moon, keeping a subsurface ocean liquid and feeding the plumes that rise from its surface. Titan experiences similar but less intense tidal effects, enough to shape its atmosphere and surface features. These forces are continuous, acting day and night, year after year, shaping moons over millions of years. The rings are also influenced by gravity. Particles in the rings follow paths dictated by Saturn's pull. Closer to the planet, the pull is stronger, and particles orbit faster. Farther out, the pull weakens and orbits slow. Small moons embedded in or near the rings create gaps and waves, shepherding particles along precise paths. The overall effect is a constantly moving, structured system, held together and shaped by gravity alone. As we observe the rings from a close perspective, subtle curvatures become visible. Individual particles are too small to see clearly from a distance, but collectively they form bands that bend around Saturn. Gravity shapes these bands, holding particles in elliptical paths, creating density waves and ripples. Shadows from moons and rings shift slowly, emphasizing the curvature and motion of the orbiting system. Flying through the environment, one feels the sensation of orbit. Movement is continuous but subtle. Accelerations are almost imperceptible, shifting gently as we move, closer or farther from Saturn. The sense of scale is immense. Distances between rings, moons, and the planet itself are vast, yet all motion is connected by gravity. The pull of Saturn is constant, a guiding force that maintains the rhythm of the entire system. Moons influence one another through gravitational interactions. Titan's mass, for instance, slightly perturbs the orbits of nearby moons and ring particles. Enceladus and Mimas create smaller but measurable effects. These interactions maintain the system's balance, preventing collisions and distributing energy gradually. Observing this, one sees the slow choreography of bodies moving under mutual influence, a precise arrangement maintained over millions of years. Tidal interactions with the rings create waves. As moons pass near the ring edges, their gravity draws particles slightly inward or outward, forming ripples that move across the bands. These waves are subtle but measurable, slowly changing over time. Each ripple carries information about the mass and distance of the moon that created it, allowing scientists to map the system's dynamics with precision. The feeling of orbit is enhanced by centrifugal motion. As we move with Saturn's gravity, objects in orbit seem to float, balanced between the pull of the planet and their own velocity. The sensation is gentle, a quiet glide along curved paths. Particles in the rings orbit similarly, following elliptical paths that prevent them from colliding with one another or with moons. The balance is delicate, yet the system has persisted for eons. Gravitational interactions also explain resonance patterns. Certain moons orbit at periods that are multiples of one another, creating resonances that shape gaps in the rings. The Cassini division, for example, is maintained by the influence of mimas. These resonances create long-term stability, preventing some collisions while subtly sculpting the system's structure. The result is a rhythm that is slow, predictable, and constant. As we move through the Saturnian system, subtle accelerations are felt. Approaching closer to the planet increases pull slightly, while moving outward reduces it. These changes are gentle but measurable. The sensation is similar to moving on a slope in a fluid, a continuous adjustment as we drift along gravitational contours. This movement emphasizes the curvature of space, shaped by mass and motion. Ring particles display tiny variations in orbit. Collisions are rare, but when they occur, the energy spreads slowly, producing small waves. Over time, these interactions maintain a smooth distribution of particles. The rings are structured yet flexible, responding to the combined gravity of Saturn and its moons. The visual effect is a continuous flowing system without abrupt changes, moving in a pattern defined by physical laws. Tidal stretching is subtle across the moons. Small variations in gravity create bulges on the surfaces of satellites, often imperceptible but measurable. Enceladus, Titan, and Dione all experience these forces. The stretching and compression generate heat, influence surface features, and even affect internal oceans. Observing this, one realizes that gravity is not just a pull toward the planet, but an active shaper of form and energy across the system. The curvature of space around Saturn is subtle but present. Close to the planet, motion follows predictable elliptical paths. Particles in the rings trace slightly curved orbits. Moons move along smooth arcs, guided by mass and momentum. The entire system appears suspended in space, held together by the invisible yet persistent force of gravity. The sensation of moving through it is gentle, continuous, and rhythmic. Saturn's rotation interacts with gravity to influence orbital motion. Equatorial bulges affect local gravitational strength, slightly adjusting the paths of nearby moons and ring particles. These variations are small but measurable. They create subtle differences in speed and trajectory, helping maintain the overall structure of the system. The planet's spin and mass together create a balanced environment in which moons, rings, and particles coexist. Observing orbits in detail, one notices elliptical shapes. No moon moves in a perfect circle. Particles in the rings follow similar paths. These elliptical motions are stable, dictated by gravitational forces and velocity. As we drift along, we feel the gentle pull towards Saturn, countered by motion along these paths. The result is a continuous glide through space, an experience of slow, measured orbital mechanics. Gravitational interactions extend far from the planet. Even distant moons are affected, experiencing small pulls that subtly alter orbits over long timescales. The rings feel this as well, responding slowly to perturbations. Over thousands or millions of years, those forces create waves, gaps, and patterns, shaping the system without violent disruption. The effect is gentle, continuous, and orderly. The feeling of being in orbit emphasizes the scale. Distances between Saturn, its moons, and ring particles are vast. Yet motion is smooth, with accelerations so gentle that they are almost imperceptible. Shadows shift slowly. Light from the sun filters through the rings. The system appears vast, dynamic yet calm, guided by forces that operate with precision and predictability. Even small particles are part of this gravitational dance. Dust, ice, and rock follow the same rules as moons, orbiting along paths defined by Saturn's pull. Collisions are minimized by careful spacing and velocity. The collective motion produces bands, gaps, and waves that stretch across the rings, a visual record of forces in action. Observing them from nearby, one feels the continuity and order of motion in every particle. Saturn's mass dominates local space. Its gravity is strong enough to maintain rings, shape moon orbits, and even influence distant comets and asteroids. The effect is continuous. The farther we move, the weaker the pull, but it remains the dominant force in the system. One senses this omnipresent influence while floating near the planet, a quiet but undeniable presence shaping every path we observe. The interaction between moons, rings, and gravity is continuous and slow. Each body responds to others, adjusting position and velocity. Energy transfers gradually, shaping patterns that last for millions of years. Tides, resonances, and orbital arcs combine to maintain stability. The system is interconnected, dynamic yet balanced, and every motion we observe is a result of this persistent gravitational network. As we drift along with Saturn's pull, one senses the curvature of space through motion. Objects in orbit follow paths that are slightly curved, bending gently around the planet's mass. Accelerations are subtle, measured, and continuous. The rhythm is slow and constant, emphasizing both the scale of the planet and the order imposed by gravity. The subtle accelerations, tidal effects, and orbital dynamics combine to create a sense of movement that is both gentle and persistent. We feel the pull of Saturn, the motion of moons, and the slow drift of ring particles. The planet's mass guides everything in the system, creating order, balance, and rhythm. Observing this, one experiences the quiet, continuous mechanics of a vast and interconnected planetary system. We begin a slow ascent, moving gently away from Saturn's dense lower atmosphere. The thick clouds that once surrounded us gradually thin out, revealing lighter layers above. Colors soften as the pale browns and muted golds shift back toward the yellows and creams of the upper clouds. The winds grow less turbulent, and motion slows, giving a quiet rhythm to the journey. Light filters through thinner layers, casting soft shadows that move gently with the planet's rotation. As we rise, the cloud patterns we observed earlier start to spread out. Storms that once dominated the lower layers appear smaller, less immediate. Their shapes remain, swirling and curling, but they are distant now, part of a larger system that extends across the planet. The Great White Spot, seen earlier during its season, shrinks in scale as we move farther, but its complexity is still evident. Jet streams maintain their bands, but the motion is now subtle, almost imperceptible. Emerging past the upper atmosphere, we see the familiar hexagonal jet stream at Saturn's North Pole. From this distance, the pattern is clear, geometric, and perfectly aligned with the planet's rotation. Its edges are smooth, colored in pale yellows and soft creams. The motion of clouds within it is slow, a gentle twisting that conveys continuity and balance. Observing from here, one understands the precision and persistence of Saturn's atmospheric systems. The rings begin to appear more prominently as we rise above the cloud tops. Thin shadows stretch across the upper atmosphere, marking the positions of ring bands. Individual particles are not visible, but the bands shimmer in sunlight, creating a layered effect that mirrors the stratification we observed in the atmosphere. The motion of particles within the rings continues, steady and precise, following paths determined by Saturn's gravity. From this vantage point, the moons are visible as small points of light moving along their orbits. Titan casts a faint shadow on the rings below, while Enceladus glimmers faintly as it reflects the sun. Rhea, Iapetus, and smaller moons move steadily, following paths that are predictable yet graceful. Each moon appears connected to Saturn, their orbits shaped by tidal forces, gravity, and momentum. The system feels complete, balanced, and persistent. Gravity is still noticeable, but gentle from this distance. Accelerations fade as we move farther from the planet. The pull of Saturn is present, but no longer immediate. Orbits of moons and rings continue unchanged, their rhythm uninterrupted. Observing this, one senses the scale of Saturn, the extent of its influence, and the precision of natural forces at work. Light changes as we ascend. Shadows from rings lengthen, fading across the upper atmosphere. The planet's curvature becomes evident, its outline smooth against the blackness of space. Sunlight reflects off clouds and rings, highlighting textures and shapes without harsh contrast. The colors shift from warm tones in the clouds to cooler pale yellows and creams, then finally into the silvery shimmer of the rings. We leave the immediate vicinity of the rings, and they stretch outward like delicate bands of frozen particles. From here, gaps and divisions are visible, including the Cassini division. Shadows trace along these gaps, emphasizing the structure and order of the system. Each band moves in harmony, guided by gravity and orbital dynamics, forming a coherent and structured whole. Saturn's magnetic field is present but invisible. Auroras at the poles can still be seen faintly from this distance, glowing as thin bands of light along the upper atmosphere. They pulse gently in response to the solar wind, a quiet reminder of the energy generated deep within the planet by metallic hydrogen and internal currents. The effect is subtle, atmospheric, and calming, a slow rhythm in the planet's presence. As we move farther, the lower atmosphere disappears from view. Storms, plumes, and cloud bands are distant. The great white spot is a small patch of brightness far below. Jet streams appear as faint lines marking rotation. Hexagonal patterns at the North Pole are still visible, but shrink in size, reminding us of the precision and persistence of atmospheric forces. The moons recede slowly into the distance. Titan remains a prominent point of light, its atmosphere scattering sunlight. Enceladus and Rhea move in steady arcs, their orbits smooth and continuous. Shadows on rings and clouds lengthen, fade, and eventually disappear. The solar reflection across the system softens, emphasizing the quiet emptiness of space around the planet. The sense of orbit and movement becomes minimal. Accelerations are gentle and almost imperceptible. Floating near Saturn, one senses the vastness of the system, the scale of rings and moons, and the subtle forces that maintain motion across millions of kilometers. Everything is connected, yet the feeling is calm and expansive without hurry or turbulence. Observing Saturn as a whole, one sees the combination of structure and motion. The planet's layered clouds, storms, hexagonal jet stream, rings, and moons all form an interlinked system. Gravity maintains orbits, internal heat powers convection, and energy flows from the core to the clouds. The magnetic field extends beyond the rings, shaping auroras and charged particle motion. The system is immense, precise, and quietly persistent. The light continues to fade gradually as we move outward. Shadows lengthen across the rings, highlighting divisions and gaps. Cloud colors soften, becoming paler, almost washed with sunlight. The planet's outline is clear against the backdrop of space, a smooth curve with subtle shading. The experience is visual, tactile, and measured. One senses both the scale and calmness of the environment. As the narrator's voice begins to recede, the sensory experience remains. We float above the rings, moons orbit below, and Saturn itself stands as a massive structured presence. The rotation of the planet is subtle but perceptible, influencing cloud motion and ring behavior. Tidal forces, orbital arcs, and gravitational pulls continue, but the feeling is distant, quiet, and serene. The focus shifts from details to the overall impression. Saturn is immense, layered, and dynamic. Storms and jet streams are part of a larger system. Rings, moons, and magnetic fields interact continuously, yet the pace is slow, measured, and precise. The planet is alive with motion, yet the experience is calm, ordered, and immersive. Light dims further, emphasizing distance and perspective. Rings stretch outward, moons follow their arcs, and the planet's curvature becomes more evident. The great white spot and hexagonal jet streams are visible as distant patterns, subtle and refined. Shadows from rings trace softly across the upper atmosphere. The motion of clouds is gentle and continuous. The system's scale encourages reflection. One senses the balance of forces, the interplay of gravity, rotation, and energy. The lower atmosphere, storms, and internal structure are distant, yet connected. The metallic hydrogen inside, the rocky core, and the internal heat flow all contribute to what we see. Saturn is a living system, coherent, measured, and immense. As we continue to move outward, the narrator's voice fades gently. Observations become quieter, thus focus shifts to space around the planet. Rings, moons, clouds, and auroras remain visible, but recede slowly. The eye is drawn to the curve of the planet, the thinness of rings, the precise arcs of orbiting moons. Motion continues, yet it is calm and steady, uninterrupted by sudden change. Finally, the scene opens to a distant perspective. Saturn is framed against the blackness of space. Rings stretch across the field of vision, casting long, subtle shadows. Moons orbit steadily. Auroras glow faintly at the poles. Light softens and blends into darkness. The pull of gravity is gentle, almost imperceptible. The system is present, quiet, and enduring. Floating here, the listener is left with a final sense of scale, motion, and balance. The journey through Saturn's clouds, storms, rings, magnetic field, moons, and gravity has revealed structure, energy, and continuity. Everything is interconnected, precise, and persistent. Light fades gently. Shadows lengthen. Motion slows. Saturn remains immense and measured as we drift slowly away into space. The narrator's voice recedes fully, leaving the listener suspended near Saturn's orbit. All observations remain in mind: the bands of clouds, swirling storms, hexagonal jet stream, immense rings, orbiting moons, magnetic field, and the pull of gravity. The planet is vast, structured, and dynamic, yet from this distance, it feels calm, composed, and complete. The last impressions are of light fading, rings stretching, and moons tracing arcs against the darkness. Saturn dominates the view, but in a quiet, measured way. Motion continues imperceptibly, gravity persists gently, and energy flows subtly from the planet into space. The experience is one of stillness, perspective, and reflection, leaving the observer calm and gently suspended in the emptiness around the planet. And so we remain, drifting slowly outward, the planet receding yet persistent. Saturn's systems, interior, atmosphere, storms, rings, moons, and magnetic presence all continue. The solar light softens across the scene, highlighting textures and shapes without abrupt contrasts. Shadows move gently, clouds fade, rings shimmer faintly, and moons orbit silently. We leave Saturn in a state of quiet observation, drifting in the calm of space with a lingering sense of wonder and perspective.